Okay. Um, Welcome to our lecture in mathematics. Today we are going to be seeing curve sketching. Curve sketching. Now, in other videos, we are going to teach you guys about data analysis because data analysis is a very important topic. It comes both in physics and in mathematics. Okay, and in pure maths. So what happens is that I am going to demonstrate to you how you sketch a curve. Alright, in this video, the different types of curve. Now this video might be divided into two parts. Okay, it depends on how far you can divide it into two or into three, depending on how far or how fast you are going to go. Okay, now please make sure you put out your sheet of paper, you jot down the things I'm going to say, try to get past these equations and try to plot some curves. Now I'll explain curve sketching to you using examples. Alright, using examples. Of course, curve sketching is an application of differentiation. Now we are dealing with pure maths. Pure math. Alright, and our topic is curve sketching. Now, the very first point you are going to note under curve sketching is that you don't sketch a curve on a graph paper. You don't sketch a curve on a graph paper. If you sketch a curve on a graph paper, your your graph is not going to be considered. It's going to be marked wrong. Why? Because it is sketching. It is not. You are not plotting. You are simply sketching. So you sketch on your answer sheet, not on the graph paper. Okay. The only thing you sketch on the graph paper is the equation that comes from for data analysis, the one you are given x and y, and you are asked to plot a suitable graph to obtain the values of x and y, as we see in our subsequent videos, the video on data analysis. So you should watch out for it, and please make sure that you also subscribe to the YouTube channel, so that by the time we release any video on any topic or in any subject, you're going to receive it. You're going to receive a notification for it. Hit the notification bell so that we should know. Okay. Now, I will try to, in this first part, I'm going to be sketching, we're going to try to sketch a graph of f of x equal to x plus, let's say x plus 3 all over x plus 1. Okay, I'll sketch a graph of x plus 3 over x plus 1, okay, which is f of x. Now, in the other part of the video, I'm going to sketch a little bit more complicated graph. Alright, like for example, f of x equal to, let's say, x plus 1 over x minus 3 into x plus 2. Okay, we will sketch a graph of this sort so that we can see how they are, what are the various points you are supposed to take note of in these different types of graphs. Now we just move forward directly to sketching the graph of f of x equal to x plus 3 over x plus 1. And remember, sometimes they will ask you to look for maybe h of g of x, and they ask you to sketch the graph of h of g of x. But no worries, we are going to release a lecture on functions, the one you talk about subjectivity, inverse of a function, and all of that. But for now, we are looking at curve sketching. Now, already when you have the function, the first thing you do is you let y to be equal to f of x. You let the function to be equal to f of x, which implies that your y should be equal to x plus 3 divided by x plus 1. Okay, this is your very first step. Now, when you are plotting a curve, when you are sketching a curve, the very first thing you need is your axis. This is at the stuff you need. The first thing is the axis. The second thing you need are the asymptotes. Of course, you have horizontal asymptote and vertical asymptotes. Horizontal asymptotes are points on the graph, or are points on the graph where the graph approaches, the curve approaches, but never touches. We are going to see that one we're going to be plotting. The curve approaches the asymptote, but it never touches the asymptote. Then the other point you are going to need are going to be the turning points. You're going to know you need the turning point for that graph. You need to get the excluded regions, and you need the curve itself. Okay, you sketch the curve. So you have axis, asymptotes, which are, you can have horizontal and vertical. This is just for maths. Therefore, further mathematics students, they are going to have another extra type of asymptote that we call the oblique asymptote. But now you have to know the horizontal and the vertical asymptote, how to look for them, and you have the turning point, the excluded regions, okay, and the curve. Now let's go to the first thing. If you want to apply all of this to this particular curve that I've done, please, I think you're following. So f of x equal to that, we let f of x to be equal to this. Let me wipe so we can have enough space, all right, to write, follow what we're doing. Now we said y equal to x plus 3 over x plus 1. So how do I look for the axis? For the axis, these are the points you are going to be plotting on the graph, or you are going to be plotting on the curve. So you have, you will say when x is equal to 0, okay, y will be equal to, you have 0 here, making y equal to 3. Now when y is equal to 0, alright, you let x be equal to 0 and then y equal to 0. Now if you let any of these stuff to be equal to 0 and maybe x gives you infinity, you should use another value of y. If you let y to be equal to 0 and x gives you infinity, use another value of y. If you let x equal to 0 and y gives you infinity, use another value of x, okay, to get an appropriate value that you can be able to plot on the curve. Alright. Now y equal to 0 will imply that, alright, 0 of course will be equal to x plus 3 over x plus 1. So when you cross multiply, you see that x plus 3 will seem to be equal to 0 because x plus 1 multiplies 0 to give us 0. So we're going to have that x plus 3 will be equal to 0, implying that x will be equal to negative 3. Okay, that is going to be our axis. So we have 2 points on the curve which are going to be plotting. We have the point 0, 3 and the point negative 3, 0. Okay, those are our 2 points. So x here is negative 3 and y is 0. Okay, then the next thing we're going to be looking at are the asymptotes. So we have the asymptotes. So we have the vertical asymptote. How do you look for the vertical asymptote? The vertical asymptote, okay, is you look for the vertical asymptote by equating the denominator to 0. So if I equate, this implies that x plus 1 is equal to 0, implying that x equal to negative 1. Okay, so for my vertical asymptote, I equate the denominator to 0 and I look for the value of x. So x equal to 1, the line x equal to negative 1 is my vertical asymptote. Now for horizontal asymptote, alright, what am I going to do? Y will be equal to, I'm going to take the limit as x tends to infinity of x plus 3 over x plus 1. Okay, x plus 3 over x plus 1. And if I take that limit, it will be the same as the limit as x tends to infinity of, I can factor out x, okay, here, this is the best way to look for it. If I factor out x, I'm going to have x into 1 plus 3 over x, okay, and I'm going to also have, if I factor out x below here, I'll have x into 1 plus 1 over x, okay, you do it that way, so this x over here takes care of this x below. Now I substitute infinity wherever I see x here, alright, this one will take care of this one, then I substitute infinity wherever I see x. So 3 over infinity is 0, 1 over infinity is 0. So it means that my horizontal asymptote, alright, my horizontal asymptote will be the line y equal to 1. Okay, because we will left 1 over 1 here, which is going to give you 1. Okay, my horizontal asymptote is going to be the line y equal to 1. Alright? So please take note of that because I'm going to wipe. So I will simply just take the axis somewhere here. I'll just simply take the axis. Our axis is the first point is the axis. So our axis will have 2 points. We have 0, 3, and we have negative 3, 0. We have our horizontal vertical asymptote is x equal to negative 1, and horizontal asymptote is y equal to 1. Okay, so we have already looked for 2 components. Horizontal asymptote, take the limit as the function tends to infinity. Alright, now let's go to the next point. After from the 5 main things I stated here, the next thing you're supposed to look for is the turning point. So for the turning point, what do? For turning point, For turning point, what you do is you differentiate the equation. Alright, remember y equal to x plus 3 over x plus 1. So we differentiate this equation and equate to 0 and look for the value of x there. Alright, so this implies that dy dx, alright, will be equal to bottom z top. Remember it's a fraction, so bottom z top x plus 1, z top will give me 1, minus top is x plus 3, the bottom is 1, you differentiate the bottom, you have 1, all that divided by the bottom squared. Okay, so this one will give me, if I open this bracket, I have x plus 1 minus into x plus 3, all that divided by x plus 1, all that squared. Okay, so bread what? Bread at turning point, okay, or stationary point, dy dx, remember dy dx is the gradient, dy dx equal to 0. Now since dy dx is equal to 0, it implies that, remember if you put 0 here in the place of dy dx, we cross multiply. So it will imply that x plus 1 minus into x plus 3 is equal to 0, because this one will multiply with 0 to give us 0. Okay, this one multiplies to 0 to give us 0, so we're left with this. So this implies that x minus x will give us 0, and 1 minus x will give us negative 2 equal to 0. So you see, there is no defined value of x in this case, and therefore no turning point. Because if you had a value of x in this case, you now take that value and substitute in the original function to get a value component of the turning point. But since there is no defined value of x here, it means that you don't have any turning point. Okay, please take note, there is no turning point. So for all equations of the form x plus a over x plus b, all right, for linear function over linear function, we are not going to have any turning point. But always you make sure that you look for the dy dx and prove that there is no turning point in every case. All right, always make sure that you do that. All right, so there is no turning point in this case. So since there is no turning point, we move to the next concept. Hope this one is very clear. You differentiate the function, you equate it to 0. Then you look for the value of x. Here, x has no defined value in the equation. Alright, and so there is no turning point. So let's go to the next concept. And you must write there why there is no turning point. You say because dy dx or dy dx equals to 0, x has no defined value. Please, you note that. Now there is no turning point, so no turning point. Okay, please you spell it out. The other thing that we're going to do is to look for the excluded regions. Okay, we're going to see why we call it, because the graph is not going to be found in every region of the curve where we're going to be sketching. It will be found in some regions, and in some regions you are not going to find it. So we're going to have excluded regions. For excluded regions, of course, we know that y is equal to x plus 3 over x plus 1. So what I do is that I equate both the numerator and the denominator to 0, and I look for the values of x from there, and then we now move forward. So what happens is that x plus 3, okay, I will say, I will look for what we call critical values. These critical values are going to be my points, alright, they are very important points to look at. So my critical values, I will say x plus 3 equal to 0, implies that x equal to negative 3, okay, and the numerator equal to 0 means what? X plus 1 equal to 0 implies, denominator, sorry, equal to 0 implies x plus 1 equal to 0, implying that x equals to negative 1. So those are my critical values then. After I equate the numerator and the denominator to 0, okay, I'm going to have the values of x. These values are called the critical values. Now arrange these values in terms of increasing order. Alright, I'm going to arrange these values in increasing order. So in increasing order, negative 3, alright, remember negative 3 will be less than negative 1, so negative 3 and negative 1. So from negative 3 you increase to negative 1. Okay. So the next thing you do is that you are going, after you have gotten your critical values, you are now going to make a table to see the regions in which the graph is going to lie. That's what we call it, the excluded regions. Okay. So what we are going to do, we are going to draw a table. Alright. Here we are going to have the function. We are going to have x plus 3 over x plus 1. And then here we are going to have, okay, please x will be less than negative 3. Okay, so if there are 3 values, you are going to have about 4 columns. If there are two values, you have 3 columns, like what we have here now. So x less than negative 3, everything is less than except the last one. So x less than, you create their inequalities. For x less than negative 3, where does the graph lie? That's what we're asking. For in between negative 3, so x less than negative 3 and x less negative 3 less than x less than negative 1. In between negative 3 and negative 1, where does the graph lie? That's the question we're asking. And above negative 1, x greater than negative 1, where does the graph lie? That's what we're asking. Okay? Now, you take a value of x which is less than negative 3. I think this is what you do under inequalities. So you take a value of x which is less than negative 3 and you substitute in the equation. And the better value of the negative 4. When you put negative 4 here, you see negative 4 plus 3 gives us something negative 1. So it's negative divided by negative 4 plus 1. So negative 4 plus 3 gives us negative 1 is negative. Here negative 4 plus 1 will give us negative 3, okay, which is also negative. So remember, negative divided by negative gives us positive overall. So it means that the graph is going to lie in the positive region for x less than negative 3. And in between negative 3 and negative 1, a good value there is negative 2. So if you put negative 2 here, you see this one is going to give me positive, okay, negative 2 plus 3 is positive 1. And negative 2 plus 1 here is going to give me negative 1. So positive over negative. And my overall here is going to be negative. Positive over negative gives us negative, and negative over positive gives us positive. And then greater than negative 1, okay, we have a value of, we can take a value like, let me say 0. Okay, 0 is greater than negative 1. So if you use 0 here, in this case, you give a positive to me, so positive divided by positive. So 0 plus 1 will give us positive, so overall is positive. So it tells us that the graph lies in the, below negative 3, the graph lies in the positive region. In between negative 3 and negative 1, the graph lies in the negative region, and greater than negative 1, the graph lies in the positive region. So we have looked for the first 4 components: the axis, the asymptote, the turning point, and the extruded regions. Now let's move on to sketching the curve. Alright, to sketch the curve is very, very simple. After you have done everything, okay, please remember our asymptotes: x equal to negative 1 for vertical and y equal to 1 for horizontal. Okay, I think that space is enough. So if I have my curve, I'm going to have the x, this one is the x-axis. Alright, this one is my y-axis. Alright, I can number here from 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4. Okay, can go. Please, you are sketching and you don't use a graph paper. So negative 1, negative 2, negative 3, negative 4. You can continue. 1, 2, alright, 3, and so on. Now, the very first thing we put on our graph is going to be the asymptotes. And the first asymptote there is the vertical asymptote. So x equals to negative 1. So you indicate asymptotes on the curve with dotted lines. Okay? You indicate asymptotes with dotted lines like that. That's my vertical asymptote at x equal to negative 1. My horizontal asymptote will be at y equal to 1. So this is going to be my horizontal asymptote at y equal to 1. This line horizontally like that. So that is it. The first thing you do is you put your asymptotes on the curve. Then you now move to the axis. Okay? Although you look for the axis first, but you first of all apply the asymptotes before you go to the axis. So for the axis, we have the first point 0, 3. So x is 0 and y is 3. So this is going to be my first. This is our first plotted point here. The next one is y is negative 3 and x is negative 3 and y is 0. So y is 0 and x is negative 3. So this is going to be one of our points here. Okay? It's going to be one of our points. Now, after we do this, since the graph has no turning point, okay, we simply just go directly to our extruded regions. So in the extruded region, below x, that's for x less than negative 3, the graph lies in the negative region. Alright? So please, the graph is going to lie below this part of the asymptote. Alright? It's going to lie, so the graph will be passing through this point. So you see the curve is going to approach this asymptote, then you will never touch it. Alright? You move like this, but it's never going to touch the asymptote. Okay? It's never going to touch the asymptote. That's for x less than negative 3. Okay? For x less than negative 3, for x less than negative 3, okay, the graph lies in the negative, sorry for that. Our asymptote here, vertical asymptote was this. Our vertical asymptote was x equal to negative 1, alright, and our horizontal asymptote is y equal to 1, okay, and our first point we saw there was negative 3, 0, alright, is clear, and for negative 3, 0, and the other point is 0, 3, which we have actually seen here perfectly, alright. Now, we said for x less than negative 3, okay, for x less than negative 3, the graph exists, okay, less than negative 3, the graph exists in the negative region, alright, so it means that the graph will surely be existing in this part, okay, and for x greater than, so for x in between, the graph exists in the positive region, okay, the graph exists in the positive region, so for less than negative 3, the graph is going to exist in the positive region, but for in between negative 3 and negative 1, the graph exists in the negative region, alright, so in between negative 3, alright, in between negative 3 here and negative 1, the graph is going to be existing in the negative region, please, this is it, alright, and for the other part, the graph is going to be existing in the positive region, okay, you see, the positive region is here, so below negative 3, you have the graph in the positive region, and in between negative 3 and negative 1, the graph is in the negative region. Now, for x greater than negative 1, the graph is going to be in the positive region again. So you see, this is the point. This point here clearly indicates that that's where the graph is going to be passing. So the graph will be passing somewhere here. So if you were to continue this asymptote up, alright, you see that the curve will come beside the asymptote. You never touch the asymptote. Pass through this point here. Okay, pass through this point. Approach this asymptote, but it is never going to touch this asymptote. So that is it, alright. It approaches the asymptote but never touches it. So you see that it is in the positive region. But here below negative 3, the graph was in the positive region here, and in between negative 3 and negative 1, it was in the negative region. Alright. So your axis is going to tell you clearly where your graph is going to form. Like here, I had no doubt. I could not insert my graphic because I knew that it was passing through this point. So I knew exactly where my graph was going to enter. So that is the end for the first part of curve sketching. In the second part of the curve sketching, I am going to illustrate very well on the plotting of the other complex curve, okay, which has many points and it has a turning point. How do you treat the turning point? I love that. So stay connected and make sure to subscribe to our YouTube channel. Thank you very much. God bless you.